Hi, my name is Raja Alagluxore. So we are from Group 5, and this is the presentation about our trip to Mersing for our geology, and this is the presentation about our trip and what we did for the 4 sites. Okay, so this is my fellow members, and I will introduce one by one. So me myself, Raja Alagluxore, and my fellow friend Nasharam and Saranya, Tuition, and Vinisha. So this is our fellow team, and we did this research, and we did our report about the 4 sites. And so for the abstract, the geological investigation focuses on field studies conducted at 4 key sites in the Mersing district: Air Hitam, Teluk Iskandar, Cerum Bantuan Las Pasilanun, and Pantai Pasilanun. The primary objective was to analyze geological processes, identify rock type, map discontinuous, and evaluate rock mass stability for engineering applications. Activity included scan-line discontinuity mapping, rock mass rating (RMR) assessment, rebound hammer strength testing, and structural analysis. Key findings reveal diverse geological characteristics, including clay and silt in Air Hitam, this interbed pyrite and quartzite in Teluk Iskandar, and pyroclastic rock in Penyambung. The project emphasized the importance of understanding geological conditions for infrastructure development, enhancing students' skill in fieldwork, geotechnical evaluation, and practical problem solving. Results provide valuable insights into site stability, geological hazard, and the role of geology in engineering design. So, for the introduction, our objectives are hands-on experience in geological fieldwork to analyze, process, rock types, and structure. Geology. Mersing features sedimentary, metamorphic, and pyroclastic rock with folds, fault, and discontinuities. Site, such as Air Hitam, Teluk Iskandar, Cerum Bantuan Pasilanun, and Pantai Pasilanun. Activities: rock identification, scan-line mapping, RMR assessment, rebound hammer testing, and groundwater observation. For structures, documented faults, foliation, bending. Data: collected rock mass properties for stability and strength analysis. Application: relevant to geotechnical engineering and environmental studies. Skill: improved mapping, identification, and data interpretation. Acknowledgements: thanks to the lecturers for guidance. Outcome: rich theory and practice preparing for geology-related careers. So, for our objective, number 1, to develop students' ability to identify rock type and geological structures. To conduct field measurement related to discontinuity, mapping, and rock mass rating. Number 3, to analyze geological structure such as fault, foliation, and bedding. Number 4, to access rock strength and discontinuity characteristic for geotechnical application. Number 5, to enhance students' field observation, data collection, and interpretation skill. So, for the site location, as you can see, our first site is Air Hitam, and our second site and a third site and number 4 site is in Mersing, as you can see in this slide. So this is our flow chart, and this is how we go for our journey. And the journey start from UTHM to IATAM, and we went to IATAM Industrial, and for sure we did our research about the rock type, discontinuous mapping, RMP, and rebound hammer. And for site 2, we went for Teluk Iskandar Mersing, and we did rock type photos, discontinuous mapping, and our third site, Cerum Pantai Pasilanun, and we did rock type discontinuous mapping, same, RMR, rebound hammer. Site 4, Pantai Pasilanun, and we did the same thing, rock type geological structure, discontinuity mapping, and we went back to UTHM, and in the end. So, this is for study area. We went for 4 sites. So each site we researched and we did a description about each site. So for the first site is Aihitam. So it's located in Aihitam region, known for its very rock formation and geological structures. It presents an excellent opportunity to study rock types, discontinuities, and the overall rock mass characteristic. The area is significant for understanding rock mechanics and its implication for construction projects. For our second site is Teluk Iskandar Mersing. So it's offer unique geological settings for the study of rock types, geological structures, and mineral composition. The site is especially valuable for examining the interaction between geological features and coastal engineering challenge. And our third site is Cerum Bantuan Pasilanun, Penyambung. So they have distinctive rock formation that are ideal for studying slope stability, discontinuities, and groundwater condition. The area is crucial for understanding rock mass stability in area prone to erosion and other geological hazard. So our last site, Pantai Pasir Lanun. So this is pyroclastic rock formation and the geological process that have shaped the area. The study of this continuous and rock mass waiting in this region is essential for evaluating the potential for coastal engineering project and identify potential geological hazard.
Hello, my name is Nashandram and my OT number is CF230169. Now I'm going to explain about IATAM, about Site 1, the geological trip we went on November 15 and 16. Okay, now we identify the rock type at IATAM. First is material identify. Clay and silt were the primary fine-grained sedimentary materials at IATAM. Clay properties composed of particles is above 0.002 mm and formed from weathered silicate minerals retaining water well and exhibiting plasticity when wet. Clay behavior: swells and shrinks with moisture changes affecting structural stability in engineering application. For the silt properties, particles range from 0.002 until 0.06 mm deposited by water, wine or ice with moderate water retention. Silt structure smooth and less cohesive than clay but impacts permeability and strength. Depositional environment indicates an ancient lake or river where fine particles settle. Engineering significance: clay and silt influence slope stability, foundation strength, and erosion. Groundwater impact: clay's water retention and permeability affect groundwater behavior. Geotechnical assessment: essential to understand material behavior for site stability and construction planning. Practical application: findings are vital for designing safe and durable engineering projects. I'm going to explain about rock mass rating, RMR. For the uniaxial compressive strength, UCS, the value we get at IATAM site is 51 MPa and the rating is 7. For rock quality designation, RQD, the value is 99.33% and the rating is 20. Spacing of discontinuous value is 521 mm and the rating is 10. condition of discontinuities, value is 16 and rating is 20. And for the fifth item, groundwater condition, the value is damp and rating is 10. So total is 67. Now is about the discontinuity data collection and item side 1. These are the deep direction and deep angle we got on side 1 item, and the slope for the item side is deep direction is 260 and deep angle is 60. First we need to plot the poles. So after that we need to do numbering. This is the discontinuity characteristic. From the contrary, we got three joint set. First joint set, deep direction is 225 and deep angle is 70. The second joint set, the deep direction is 234 and the deep angle is 38. And the third joint set is deep direction 299 and deep angle is 61. From the joint set, we need to the discontinuity sets from the slope and friction angle, and we got the new plan. Now we're going to see the type of failure at item site. For the mode of failure circular, the criteria is 3 joint set, the rock block, and no circular failure. The second mode failure is planar. The criteria is slope deep direction plus minus 20 degree. So the our slope deep direction is 260 plus minus with 20 degree. So we get 240 to 280 the range. So no joint fulfilled criteria 1. The second criteria for the planar is slope angle need to bigger than plane angle, need to bigger than friction angle. So the slope angle is 60, no plane angle, and the friction angle is 30. No planar failure fulfill criteria 2. Second mode of failure is wedge. For the criteria, first is slope angle need to bigger than intersection 2 angle, need to bigger than friction angle. So slope angle is 60, the intersection angle is 11 degree, and the friction angle is 30. So wedges 1 is joint 1 and joint 2 not fulfilled. Slope angle 60 degree, intersection 2 angle need to be bigger than friction angle for the criteria 2. So the 60 degree same is 60 degree and it's bigger than 30 degree. So the wedges 2 joint 1 and joint 3 not fulfilled. The third criteria for slope angle need to bigger than intersection 2 angle, need to bigger than friction angle. The slope angle is 60 degree and then intersection 2 angle is 38 degree and the friction angle is 30 degree. So wedges 3 joint 1 and joint 3 fulfill the criteria. Therefore wedges failure okay. The mode of failure is toppling and the criteria is no toppling failure in this site. Now we're going to see about factor of safety for the wedges 3. Wedges 3 is the joint set 2 and joint set 3. For the joint set 2, the deep direction is 234 and the deep angle is 28. For the joint set 3, the deep direction is 299 and the deep angle is 61. For slope angle is 260 and deep angle is 60 degree. For the upper slope, the deep direction is 270 and the deep angle is 60. YR equals to 25 kN per m square, HT equals to 50 m, CA equals to CB equals to 50 kPa, is equals to 50 kN over m square. Lambda W is equals to 9.81 kN over meter cube. Theta A is equals to theta B equals to 30, it's a friction angle, and the A equals to 38 degree, B is 61 degree, and the 35 is 38 degree. The value all we get from the drawing, the modes of failure drawing. Okay, to calculate the factor of safety, we need to find A, B, X, Y. To find the X equals to sine theta 2 4 over sine theta 4 5 cos theta 2 and A. So equals to sine 66 degree over sine 32 degree and cos 109 degree is equals to negative 5.295. To find Y, we need to use this formula sin theta 1 3, sin theta 3 5 and cos theta 1 and b is equals to sin 102 degree over sin 62 degree cos 57 degree is equal to 2.034. To find A is equals to cos A cos B cos theta NA and B sin 5 sin square NA and B is equals to cos 38 minus cos 61 degree cos 54 degree, sin 38 degree, sin 54 square equals to 1.248. To find b is equals to cos b minus cos a, cos theta and a and b over sin 5 sin theta and a and b over 2. So equals to cos 61 minus cos 38 degree cos 54 degree over sin 38 degree sin square 54 degree is equals to 0.054. The formula of vector of safety is 3 over yr hd bracket cax plus coy bracket plus bracket a minus yw over 2yr x bracket tan theta a plus b minus lambda w over 2yb multiply with y bracket tan theta b. Using the formula, we can get 3 over 25 bracket 50 times y 50 minus 5.295 plus 50 multiply with 2.034 plus bracket 1248 minus 9.21 over 225 bracket negative 5.295 bracket multiply with tan 30 degree plus bracket 0.054 minus 9.81 over 2 multiply with 25 and then multiply with 2.034 bracket and multiply with tan 30 degree. The answer we got is 0.730. It's lower than 1.0. So weight 3 is unstable. Discussion for site 1. At Ayatam, the primary rock type identified were clay and silt, fine-grained sedimentary deposits that are highly sensitive to moisture content and external load. The calculated rock mass rating RMR of 67 categorized the rock mass as a good rock, suitable for engineering projects with minor support requirement. Discontinuity mapping revealed joints with an average spacing of 5 to 1 mm, each while moderate, indicate the potential for blocky failure if stresses exceed the rock's shear strength. The damp groundwater conditions observed during the investigation highlight the critical risk the clay is known to swell when wet, potentially leading to slope instability or settlement issues. Shear failure and slip along discontinuities are the most likely failure mechanisms in this area, especially in cases of increased groundwater pressure or heavy loading. Mitigation measures such as adequate drainage and slope reinforcement should be considered to reduce this risk.
Selamat sejahtera Doktor, nama saya Tivishan Laki Sivadas, nombor matrik CF230084. Saya ingin explain tentang site kedua iaitu Teluk Iskandar dekat Mersing. Di dalam site Teluk Iskandar Mersing terdapat 6 jenis batuan. So first of all, kita dah tiba dekat site, mereka suruh kita cari 6 jenis batu dan cari 6 jenis batu, and then we have to know their name of each batu. So ini yang batu yang kita dapat, the type of rock yang kita dapat. So yang pertama adalah foliated rock like phyllite formed under pressure, aligning minerals. Phyllite fine grained with a silky sheen reveals metamorphic history. Yang kedua adalah quartz vein. Quartz veins form in rock fractures through silica-rich fields, often hosting gold or silver. They reveal hydrothermal and geological history. Yang ketiga adalah foliated. Foliated rock form under directional pressure, aligning minerals like mica. Example include slits, shields and gneiss, indicating metamorphic conditions. Yang keempat adalah quartzite. Quartzite, a durable metamorphic rock from sandstone from under heat and pressure. Its strength make it valuable in constructions. Yang kelima adalah folded. Folded rock deformed by compression force from bends like anticlines and syncline, revealing tectonic history and aiding geological studies. Yang keenam interbanded, which is quartzite and also phyllite. Interbanded quartzite and phyllite features alternating layers, reflecting shift in depositions Metamorphic condition and tectonic activity in geological histories. So seterusnya, discontinuity data collection. So daripada sini, setelah kita dah cari type of rock and seterusnya, kita move on kepada satu jenis batuan, and dekat situ kita kena cari dia punya deep direction and deep angle. So group kita berjaya dapat 20 jenis deep direction and deep angle. So daripada deep direction and deep angle, kita start buat dia punya plot the poles dekat dia punya graph, and then after we done the plotting and we doing the numbering section lah for the graph. Seterusnya untuk discontinuity characteristic. So daripada plot the graph and also the numbering section, setelah kita dah habis, so kita akan start kepada contouring. So kita kena buat dia punya contour dekat dia punya bahagian lah. So daripada situ kita dapat 3 jenis joint set, iaitu J1, J2 dan J3. So J1 dia punya DD dengan DA adalah 218 dan juga 79. Untuk joint set yang kedua adalah 173 dan juga 42. Joint set yang ketiga adalah 72 dan juga 24. So daripada joint set yang kita ada, kita plot dia punya discontinuity set dan dia punya gambaran telah ditunjuk, dan dia akan gambar macam ni lah. So daripada ni yang kita dapat. Jadi seterusnya adalah type of failure. So daripada type of failure ni, kita kena refer daripada kita punya discontinuity sets. So kita tengok untuk circular joint set, 3 joint set, iaitu rock block and also no circular failure. Untuk planar, slope direction plus minus with 20 degree. So kita punya slope adalah 45 darjah plus minus 20 darjah. So kita akan dapat 25 hingga 65 range. So kalau tengok daripada 25 hingga 65 range, kita memang tak ada joint yang fulfill. So jadi kita buat satu kesimpulan, which is no joint fulfill criteria 1. Yang kedua, slope angle lebih besar daripada plane angle dan lebih besar daripada friction angle. So slope angle adalah 70 degree, plane angle memang 0, and then friction angle kita ambil daripada lab 4 30. So kalau tengok, dia memang tak ada kriteria juga yang fulfill untuk nombor 2 ni. So yang ketiga adalah wedge. Wedge dia punya ini adalah slope angle lebih besar daripada intersection 2 angle dan lebih besar daripada friction angle. So which is slope angle adalah 60 darjah lebih besar daripada 0 darjah, dan 0 darjah lebih besar daripada 30 darjah. So jadi dia pun sama juga, not joint fulfill. So yang keempat adalah toppling. Dia punya formula adalah slope deep direction plus minus 180 darjah plus minus 10. So slope deep direction kita dapat 45 darjah plus minus 180 darjah plus 10 darjah. So kita akan dapat 210 darjah hingga 235 darjah. So jadi dekat sini kita ada fulfill, which is J1 fulfill the criteria. And next adalah 90 darjah tolak 70 darjah tambah 30 darjah kurang daripada Y. So which is 50 darjah kurang daripada 79. So which is kat sini kita dapat fulfill the criteria, yang itu adalah J1. Next, for the discussion for the site 2, the rock at Teluk Iskandar include interbanded phyllite and also quartzite. Phyllite foliated texture creates planar weakness, while quartzite durability can be compromised by fractures. Scanline mapping shows joint faults and fault, indicating tectonic deformations. Rainwater infiltration increase failure risk, requiring engineering design for slope stabilizations and effective water drainage. That's all from me. Thank you.
Good day everyone. Today I'm going to explain about the site 3 is Ceron Batuan Pantai Tanjung Penyambung. The next is identify the rock type. Pyroclastic stuff is an igneous rock formed from volcanic ash, pumice, and fragmented rock ejected during eruption. Later compacted and lithified, it varies in composition and texture, serves as a lightweight building material. and provide valuable insights into volcanic history and eruption dynamics. The next is rock mass rating, RMR. The first one is uniaxial compressive strength. The value is 25 MPa. The rating is 2. And the next is rock quality designation. The value is 82% and the rating is 17. And the third one is spacing of discontinuous. The value is 421 mm, the rating 10. And then condition of discontinuous, the value is 9 and the rating is 10. And the last one is groundwater condition. The value is completely dry and the rating is 15, so total 54. Okay, next is discontinuity data collection. We have collected 20 data of deep direction and deep angle for the graph. The first one is plot the poles. After the plot the poles, we do the numbering for the graph. The next is discontinuity characteristic. We got two joints. The first one is joint 1 and the deep direction for the joint 1 is 157 and deep angle is 42. For the joint 2 is 198 and 13 for the deep angle. After that, we started to do the contouring. Okay, next is type of failure. So got 4 types of failure. The first one is circular, planar, wedge and toppling. The first one is circular, 3 joint sets, rock block, no circular failure. The second one is planar, slope deep direction plus minus 20, 185 plus minus 20, so we got the range between 165 to 205. This is the range, so no joint fulfill the criteria. So the third is wedge, slope angle bigger than intersectional to angle bigger than friction angle, so 60 degree bigger than theta 45 degree and not joint fulfill. And the toppling also no toppling failure. The last is discussion for the site tree. The site consists of pyroclastic stuff, a fair quality volcanic rock. RMR is 54, requiring moderate engineering support with closely spaced structures 421, suggesting the potential for toppling failure or rockfall on steep slopes, while dry groundwater condition enhance short-term stability. The porous and lightweight nature of the rock increase the risk of long-term weathering, weakening and erosion. Recommended measure includes slope stabilization using retaining walls, shotcrete or rock bowls along with the water infiltration, control through surface sealing or drainage system.
Good morning, Doctor, and I am Vinisha Omador Harikumar, and I am going to present the site 4, which is Pantai Pasir Lanon Penyambung. The thing that I am going to present is identify rock type, which is pyroclastic rocks. They are formed from fragments of material ejected during explosive volcanic eruptions. These fragments include ash, pumice, and rock shards that are expelled into air and later settle to form a deposit known as pyroclastic flow or fall deposit. Examples of pyroclastic rock include tuff and agglomerate, which can vary in size from fine ash particles to large volcanic plumes. The texture of this rock is usually coarse or fragmented depending on the size of the particles. These rocks are important indicators of volcanic activity and provide valuable information about eruption dynamics and depositional environment. As shown in the image, we conducted fieldwork to examine pyroclastic rocks in the natural setting. By studying this rock, we can better understand past volcanic activities and its impact on surrounding environment. Building on what we have discussed in the previous slide about pyroclastic rock, now we are moved on to discontinuity data collections. Understanding the structural features of rock fermentation, including pyroclastic rock, is crucial in geological studies and engineering applications. On the left, we have the table displaying deep direction and deep angle measurements collected from the field. These values represent the orientation of discontinuities such as fractures or joints within the rock mass. Identifying these features is important for assessing the stability of rock slopes and potential failure risk. In the middle, you can see the stereonet where we have plotted the poles based on the data collected. Each plotted point corresponds a measured discontinuity, allowing us to analyze their spatial distribution. On the right, we have a more detailed representation where all plotted poles are numbered. This helps us systematically identify joint sets and structural patterns that influence rock mass behavior. By integrating this structural analysis with our previous study of pyroclastic rock, we can better understand how geological process and rock discontinuities interact, ultimately contributing to safer engineering and environmental assessment. In the previous slide, we plotted discontinuity data on a stereonet. Now we analyze its characteristics to identify major discontinuity sets. The table on the left shows deep direction and deep angle of key joints, which is J1 192 over 78, 256 over 86, 330 over 78, and 81 over 88. Below it, the stereonet plots these sets, helping us understand rock mass structure. On the right, contouring highlights areas of high pole density, showing dominant joint orientations. This is crucial for assessing rock stability and predicting failure zones. By combining this with our previous data, we gain a clearer understanding of geological hazards and engineering safety. Come along with this slide explores the types of failure that can occur in rock slopes based on discontinuity sets, focusing on circular, planar, wedge, and toppling failures. For circular failure involving three joint sets, no evidence of failure is identified. Planar failure is analyzed using two criteria, which is slope deep direction within 25 to 65 degree and slope angle greater than the plane angle plus the friction angle, which is 70 is bigger than 30. Both criteria are not fulfilled. Wedge failure determined by the intersection of two joint sets with the slope angle exceeding the intersection angle plus the friction angle 70 bigger than 30 is also not satisfied. Lastly, toppling failure evaluated by the slope direction, which is plus minus 180 within the range of 210 to 235, shows no joints meeting the criterion. The stereonet diagram illustrates the orientation of discontinuities, confirming that none of the specified failure modes occur under the given condition. Discussion of our site 4 is the geological setting at Pantai Pasir Lanun is primarily composed of pyroclastic rock, indicative of explosive volcanic activity. Discontinuity mapping conducted over 2 meter scan line reveal high variable joint orientation, which could potentially result in complex failure mechanisms such as wedge failure or rockfall, particularly in areas with steep slopes or cliffs. Although groundwater was not observed during the investigation, the porous nature of the pyroclastic rock makes them highly vulnerable to water ingress, which can accelerate weathering and weaken rock strength over time. Additionally, coastal erosion exacerbates the issues as wave action and weathering process could destabilize rock faces near the shoreline. This finding emphasizes the necessity of implementing a robust coastal engineering solution, which is seawall, slope reinforcement, and regular monitoring to detect and mitigate potential failure early. Despite their initial stability under dry conditions, pyroclastic rock require long-term management strategies and address erosion and water-related weakening effectively. That's all from me.
So, thank you, Vinisha. So, for the conclusion, this project provides an in-depth understanding of geological process, rock properties, and their importance in engineering applications. Field investigation at Air Hitam, Teluk Iskandar, Cerem Bantuan Pasir Lanun, and Pantai Pasir Lanun involve activities such as rock identification, discontinuity mapping, RMR, calculations, and structural analysis. This hands-on experience allows students to bridge theoretical knowledge with practical application, highlighting diverse geological conditions and challenges like failure mechanism and groundwater influence. The three foster critical skill in geotechnical analysis, data collection, teamwork, and problem solving by addressing complex structural features and environmental conditions. It emphasizes geology's role in infrastructure development, site stability, and sustainability, while exposing students to the complexity of Earth systems. Overall, this experience prepares students for future careers for cultivating technical expertise and deeper appreciation for the dynamic relationship between geology and engineering.